So what we're going to do here, in our last lecture in this chapter on summarizing data, is talk about how we can kind of bring these two concepts together. Right? We talked about visual ways of summarizing the data, and then we talked about numeric ways of summarizing the data. So what we're going to do with these things called box plots is we're going to look at a way to take the numeric measurements and summarize them visually. So here's how we're going to start. So to create this box plot, I'm going to start by finding this thing called the 5-number summary. Those are these 5 points I've got over here on the right-hand side. It's the minimum, the maximum, and all 3 quartiles. So looking at my data, the minimum is 0.3. The maximum is 0.91. And the quartiles, it's conveniently sorted into 4 evenly sized columns. So the first quartile is 0.63. The second quartile, or the median, is 0.74. And the third quartile is 0.83. So now I'm also going to need the IQR and these outlier fences. That's if you watched the last lecture on outliers. The outlier fences, that's that median plus 1.5 the IQR, and the median minus 1.5 the IQR that we found to determine where we might have outliers. So let's do this here. The IQR is Q3 minus Q1. So that's 0.83 minus 0.63, which is 0.2. Then these fences, it's the median, that's 0.74 plus 1.5 times the IQR. And that's the upper one. Let's do the lower one here. That's minus. And the upper one is 0.74 plus 1.5 times the IQR. All right, so you do the numbers here. This is 1.04, and this one is 0.44. Excuse me, 0.34. A little arithmetic error. There we go. All right, so hold on to those numbers. Okay. Here's how we do this, and I know there's a lot going on here. It gets a little cluttered. Over here on the left-hand side, these are all the values we found on the previous slide, plus the one outlier, the one number that was outside of these two fences here. And on the right-hand side, I've just got a summary. Right, I've got a summary of the steps we're going to go through. Right, so you can, if you want to go over them yourself, right, read through them. You can pause. Then we'll go through these one at a time and see how we can use these to draw this box plot. All right, so step number 1: draw a number line long enough to include all the data. So I'm going to start with a number line, and it has to include all the data. So I'm going to put the minimum value, and the maximum value. All right, so now my next step is going to be to locate all of these other values on it. And, you know, I've got to figure out where is Q1, where is 0.63? Well, it's in there somewhere, right? So what I like to do, right, I'm going to put a mark here right about where 0.4 is. I'm going to put another mark up here where 0.9 is. And then I'm going to put marks on here every tenth of a unit, right? So this first one here is 0.4. This is 0.5, 0.6, 7, 8, and 9. Now those aren't actually part of the box plot. In fact, I'm going to take them. I'm going to take them out at the very end. Right, but I like to just kind of put those in there in the meantime, just because they help me to locate these other things precisely. All right, now I'm going to draw a box around Q1 and Q2. All right, well, let's see. Q1 is 0.63. 4, 5, 6.63 is right about here, and 0.74 is right about here. So if I draw that box, I get this. All right, then I have to do it again for Q2 and Q3? Well, Q3 is 0.83. That's about here. So there's my second box. Right? So you can kind of see already, if you look at this, kind of see how my data looks like it's going to be a little skewed to the left. Right? Because the body of the data is on the right-hand side. I've got some low points that are stretching it out a little bit that way. Okay, but let's keep going here. Let me clear up my notes. Next, I'm going to determine the location of the upper and lower fences. Remember, that's 0.33 and 1.13, and I'm going to locate them on the graph. So I'm going to kind of extend the line out to 1.13. Now, if you look over on the other side, I'm going to extend that section out to 0.33. Right, so that's step number 2. Right, now, actually I did step 3 altogether. Draw lines out to those values. Right, so that's steps 1 through 3. Now the last thing I'm going to do, I'm going to draw little stars, little asterisks at any point outside of the fences. Those are my outliers. Right, another way to say this is put asterisks at outliers. In this case, we only have the 1, 0.3, and there you go. Right, that is, it's almost my box plot. I got to clean up, right? Because I said I was going to take out my little guidelines there. So if we take them out and we take the numbers out, right, what I'm left with is the box plot. And the box plot is a purely visual representation. There usually aren't any numbers on it at all. Okay, so and again, right, what can we infer from this? Well, here I'm seeing the box is where the majority of the data is. Right, most of the data is usually going to be between Q1 and Q3. So I'm seeing that my data is mostly kind of the body of the data is shifted to the right, which suggests that my overall data is skewed to the left. Okay, so this is the end of our discussion of kind of summarization methods, right? Ways that we can summarize and organize the data. So what we're going to do in the next section, we're going to take what maybe feels like a little bit of a diversion, but I need you to just bear with me. All right, we're going to talk about something called probability. And the reason we do this is our first step into inferential statistics. Right? Now we're going to start looking outward. We're going to take a sample and use it to try to make statements about the entire population. Right? And there's always going to be some inherent uncertainty in this. There's always going to be this possibility that we just accidentally got a hold of a bizarre data set, one that for some reason has a bunch of outliers in it, for example. And that's where probability is going to come in. Probability is the tool that we're going to use to quantify, and in a lot of our calculations, is what we're going to use to try to minimize that likelihood that something really strange happened.